Hello everyone, today again I Lakshmi Negi with you with my new video. In this we will explain the exercise 1. We will discuss this exercise 1.4. What we have to do in this exercise, visualize 3.765 on the number line using successive magnification method. Successive magnification. So how we will do it? For that we have to locate this point on the number line. So what will be the process of this question? So I will explain you with doing myself. Now you have to locate 3.765 on the number line with the successive magnification method. So how we will solve it? First we will make a number line for that. So as I have made, you will also make in your copy, and you will locate 0, 1, 2, 3, 4 like that. Now we require 3.7. just have a look on 3.7 only first. So we required 3.7. So and we know that 3.7 is lies between 3 and 4. So we will again split it like this. So we will write it, it's 3 and it's 4, and again we will divide this line in again 3 times, like 3.1, 3.2 and up to so on, like that we will do it. As you can see that I have divided now this line again into the 10 parts, like 3.1, 3.23 and till then 3.9. Now again I will see that I have to locate 3.76. So I will see that 76, it's 7. That means 76 will lie between the 3.7 and 3.8. So again we will split it like that. It's 3.7 and it is 3.8, and again we will divide this line into the 10 equal parts, like 3.71, 3.72 and up to so on. I have divided this line 3.7 to 3.8 again in 10 equal parts. Now you can see that we have to locate 3.765 and 765. This 65 will lie between the 3.76 and 3.77. So again we will just split it into 10 equal parts like this. So it is 3.76 and it is 3.77, and again we will divide this whole line into the 10 equal parts, like 3.761, 3.762 and like that. So as I have divided, again you can see that in 10 equal parts, 3.76 to 3.77, like 3.761, 3.762 like that. But we required the point 3.765, and now we will see over the final line, we will see that this is the 3.765. So this is the actual point which we required. Now I will explain you the next part, and I want to say you that this process is known as the successive magnification method. The next question we will also do with the same method. This is the second part of the question, in which you have to locate 4.26 bar on the number line, but up to 4 decimal places. 4 decimal places because you know that this is the non-terminating repeating number. We can write it like 4.262626 like that, but we have to locate it till the 4 decimal places. So how we will write it? 4.26 and 26. Now we have to represent this on the number line. For this again we will do the same process. You can see that first we will write this, make this number line, and we will write 0, 1, 2, 3, 4, 5, 6. Now this number will lie between 4 and 5. So we will again just split it like this, 4, 5, and we will again write 4.1, 4.2, 4.3, 4.5 and carry. So now you can see in this question, the solution of this question, the 4 and 5, we have written the 4 and 5, and or you can make the number line like 0, 1, 2, 3, 4, 5, and you can split it like 4 and 5 he has just skipped one line from that. So 4 and 5 we will write like that, and we will again divide the 4 and 5 into the 10 equal parts, like 4.1, 4.4.3 and 4.4, like till then 4.9. But we required 4.26, so 4.26, so we will 4.2 and 4.3. So 4.2 and 4.3, and again we will split it into the 10 parts, like 4.21, 4.22, 4.23 and so on. Similarly, now we required 4.2. We know that now we will see that 4.26. So I required 4.2626. Again we need 4.262. So we will write it 4.2, 4.26 and 4.27. And again we will divide into the 10 equal parts, like 4.216, 4.262, 4.263 and so on. And similarly we will again divide, because we require the 4.2626, so we will write 4.262 and 4.263, and again we will divide into the 10 equal parts. And now you can see that this is the final point, which is 4.2626. Now we will move to the next exercise. Now in exercise 1.5, what we have to do? We have to classify the following numbers as the rational or irrational. The first question. In the first question you can see that root 5 is irrational, so definitely this number is also irrational. But in question number second you can see that if we will open this bracket, so you will see that root 23 both will cancel each other and the answer will be 3, hence it is a rational number. And the next one is root 7 will be cancelled to the root 7 and the answer will be 2 upon 7, it again a rational number. Now see the next fourth question. This is root 2 is irrational numbers, hence this is also irrational number, and pi is irrational, therefore 2 pi will be irrational. Now the question is arises, just I want to clear you that in question number 1 third part, it is 2 upon 7 and it's pi, and this is also this can be written as 22 upon 7, so it is 44 upon 7, it is 2 upon 7 and it is 44 upon 7. So why this is rational and this is irrational? Because this is irrational because when we divide the 44 by 7, the number does not repeat, the dividend does not repeat, so it's a irrational number. But when you divide it by, you will get a non-terminating and repeating number, hence it is a rational number and it is a irrational number. Now we will move to the next question. Simplify each of the following. So first we have to simplify this, and then this, and then these all we have to simplify. So I will solve these questions and I will explain these also. See how we will do these questions. The first part. So this is the first part in which we have to simplify these two. So you can see that when we simplify these two, we will, because we cannot use any identity in this, so we will direct multiply the 3 by this whole bracket plus root 3 by this whole bracket. When you multiply 3 to 2, 3 to just 6 and 3, you know that 3 and root 2 are the unlike terms, they cannot be multiplied together, so we will get 3 root 2. Similarly root 3 and 2 to root 3 and root 3 and root 2, these are like terms, so they can be multiplied together, root 6. But these all are unlike terms, so we cannot solve these together. Now see the next part, the second part, 3 plus root 3 and 3 minus. You can see that in this we can apply the formula a plus b and a minus b. It's a plus b and it's a minus b, which is equal to a square minus b square. So in the place of a we will write 3 square minus root 3 square. 3 3 is 9 minus root 3 square is 3, and we get answer 6. If you will see the part, the one more part which is just similar to the part second, and this is part fourth. This part fourth and part second both are similar to each other. And in question number third, how we will solve? You can see that it is the a plus b whole square, so we have to use the identity a plus b whole square, which is a square plus 2ab plus b square. Now in the next question, I told you earlier also, it is the, we will apply the a plus b whole square formula. Root 5 a square and root 2 square. A square plus 2ab plus b square. As you know that root 5 square is 5 and root 2 square is 2 and it's 2 root 10. So now we will add these two because these two are the like terms. So 5 plus 2 equal to 7. 7 plus 2 root 10. This is the final answer of this question. Now see next question students, recall pi is fine as the ratio of the circumference is c of the circle of its diameter d and pi is equal to c upon d. This seems to be contradict the fact that pi is rational. How will we resolve the contradiction? First you should understand that what is given in the question. As we know that all the numbers in the form of p upon q are known as rational numbers. Now you can see that if we write pi as c upon d, where c is circumference and d is diameter, so how can we say that pi is irrational? Because it seems that it looks like a rational number, so how can we say that it's a rational number? So if we solve c and d, we will get the value pi, and we know that the value of pi is 22 upon 7, and which is a irrational number. So that we can say that this is a irrational number. Or we have one more explanation of this question, that as we find out the value of c and d by the measurement, we know that we get the approximate value, and if we find out the division of these two, we get the value of pi as irrational. Now see the next part of this question, represent root 3 9.3 on the number line. So how we will solve? So for representing root 9.3 on the number line, what will you do? So you have to draw it with the help of compass and ruler. So first you will draw a line of 9.3 centimeter. It should be of 9.3 centimeter. Now you will increase this line as 1 centimeter more. It should be 1 centimeter. Now this line must be divided into two equal parts. So for that we have to take an arc from there which must be equal to more than half of this line segment, and you will cut an arc from there, and you will cut here and the same arc you will take from here and you will cut downward, and similarly from this the same arc you will cut upward and downward. Now you will join these 2 points and you will get this line, which is the bisecting line of this the whole line. Now you will take an you will put your compass here and your pencil here, and you will take an arc like this, and this arc will join this line at this point. If your construction is correct, it must be joined at that point. Now at this point you will draw a perpendicular line, and you will increase this line also. Now you will draw a perpendicular line, and from this perpendicular line you will take an arc. You will put this arc on your compass and you will just cut this arc, or you draw this arc, and this arc will meet this line at this point, and this will be the 9.3 point. Thank you very much. The further questions we will solve in the next video.